Hello everyone, my name is Jacob and today I'll be presenting my Capstone 1 project on analyzing global tech salaries in the field of AI and machine learning. So this project uses a dataset of salary records for tech roles in 2025, or just 2020 to 2025, and this project basically utilizes this data to try and find and explore relationships and patterns between the different factors that are also listed inside the database. And this database is found on Kaggle and is titled Data Science AL and Machine Learning Job Salaries in 2025. And as you can see here with this image, the database does contain information about jobs such as their experience level, employment type, salary, and just other factors. So the factors that I will be going over today is there are 6 main ones. The first one is experience roles, second is remote working, third is the geographic location, fourth is the company size, fifth is the job title, and sixth is the year progression. So the first factor, or before we cover the factors, we're going to go over the initial code. So to actually analyze this data, we first have to import some libraries. So I imported 3 libraries: Pandas, Seaborn, and Matplotlib. And these libraries are all used in specific ways. Pandas are used to gather the data from the CSV file, and Seaborn and Matplotlib are both used to actually visualize and create graphics of the data. And as you can see here, the data frame is initialized by reading the CSV file that is listed. So the first factor that we'll take into consideration is role or experience. So this factor is basically what level and how does it affect what level of the job, the employee working that certain job, how does that affect their salary, and what experience do they have that could actually affect their salary. So the database contains 4 levels of experiences and many roles. There's over 100 roles. So to actually do this, we first have to define the level order, because without it, it would just sort by alphabetical. And if we do define the level order ourselves, it does make the experience level more clear. And then we get our information that we want by using the data frame. And since we're trying to sort by experience and role, we first use experience level as the X with job title, and then the salary will obviously be the Y-axis. And so we plot this data, and from this we get this graph. And this graph basically showcases the many different jobs that are all in these different arrays of colors, and it also showcases their average salary. So as we can see from these colors, we can see that there is a trend that on average a role will earn a bigger salary when the experience does go higher. Now for also role experience, we also wanted to graph the experience level, and we wanted to showcase the top 5 and bottom 5 paying jobs for experience level. So what we did here was we gathered the top 5 and bottom 5 paying jobs for each experience level, and it's listed in this graph down here. And while this graph is not necessarily very big due to space constraints, we could see that the biggest jobs that pay the most money are all usually very high profile jobs that are not very easily recruited for. So the second factor that we'll focus on is the remote work and salary. So similar to what we did for the roles and experiences, we gathered the data from the data frame, and this time we grouped by the remote ratio, which is the ratio they are allowed to work at home, and we also use the salary in USD for the y-axis. And after graphing, we could see that there isn't necessarily a correlation between the pay and how much they can work remotely, because while it does suddenly dip when they have to work around 50% at home and at work, the 0 to 100% are still relatively the same. The third factor I used is the geographic salary differences, which as the title mentions is basically how does the country you are in affect your pay. So again, just like the last few factors, we have to group the data by the column that we need, and for this factor, we need the employee residence column. So we have that as the x-axis, and then we use the salary as the y-axis like always. And as we can see here, we rated the top 15, and by looking at the countries, we could see that these countries that are all in this list are usually all very well developed. However, there are some exceptions, such as Venezuela here, and we could also see from this that the pay doesn't necessarily correspond with the population, but rather the gross domestic product per person of that country. The fourth is the company size impact. So depending on the company size, we decide to check the average salary for that company size. So again, just like before, we would get our data by using the company size column, and with this column we could then graph it. And as we can see here, while there isn't necessarily a linear correlation, we can see that smaller companies do pay on average less salary than bigger companies. So the fifth factor is job paying job titles, top paying job titles. And as before, we gather the data by sorting through the job title column in the data frame, and we basically graphed the top 10 highest paying job titles. And we can see here, these are all the job titles. Now if we do look at the jobs, we see that all of these jobs are usually high pay because of the person being a very high profile in that company. As we see, lead manager, lead architect, director. We can see these are all like very high profile people in the company, as such will receive higher pay. And the last factor I decided to check is the salary change over time. So as before, we get the year salary by using the data frame, and we can see that the pay or average salary over the years has increased while during COVID. However, this increase can't necessarily be a result of COVID, because the average salary for USD does not actually like get severely impacted by COVID itself, but rather the employees themselves, because the average salary does not get cut, but the employees do. So we cannot judge this correlation based off COVID alone, but it is just a factor that we must consider. So the conclusion for all this data is that there are patterns and relationships, as I've demonstrated, between certain factors that have impacted salary, but the correlations built from this data aren't necessarily like full, because the correlation built from this data only is a result of the data and does not necessarily cover other factors that have potentially impacted, because the data only provides certain numbers and information about the user, but does not explain external factors. As I mentioned before in the previous slide, COVID was a huge factor that definitely laid off employees in early this decade, and but none of the data actually reflects this potential factor. And the final conclusion for this project is that while the data does give an initial correlation that can be used as data, the data itself does not conclude and give a concise answer that can be used as an objective correlate.